Right then, so part 2 on the 6v6 GT push-pull amplifier. So today I finally got round to making up some Molex connectors, so the ones that are twisted together will be used in the final amp. They're a bit longer than they need to be, but I can chop them down. And as you see this spaghetti mess here, this is just hooking the two transformers up together. It's just a resistive dropper for the heater. So it's just running a AC heater, just this one valve at the minute. So yeah, the power supply board there, that's taking it present. It's running about 270 volts in, 200 coming out. A small amount of filtering on board here. There's a second stage of just resistive capacitive filtering for the triode. It just helps quieten any noise down, and also it just helps isolate this supply from the rest of it. You can end up injecting all transients and voltage pulses through the HT rails. It can cause motor boating and various issues. So just a small resistor and capacitor combination can pretty much eliminate that. So yeah, the two transistors here are the constant current sinks for the long tail pairs. This is the two long tail pairs here. They'll be capacitively coupled coming out on the Molex connectors. Those will be going to the valves on the output stage. So here's the return. Here's the blue is the cathode out to each section of the triode, and the white is the anode return. In the anode return, it's capacitive coupled, and obviously standard. Imagine you had like a valve long tail pair circuit from an input stage, something like you'd see on a Mullard 520 or something. This is pretty much the same thing, but just done with transistors, and rather than a resistor as the tail, it's got a constant current sink. It just works better. So input stage will connect here. As this is the signal wire out to the grids on the valve, and this is just the cathode bias and cathode feedback networks that the valve will see. So yeah, all at present running quite nicely. Just been testing some voltages. There's about 90 volts across each section in the triode, which is about where I want it. These have got about 20 volts across them each, so they're dissipating about 80 milliamps. These have all got about 75 volts across them. They're running at 2 milliamps, so they're dissipating about 150 milliwatts. So yeah, these are having a pretty easy time. These are getting a bit warmer, but I can put my finger on them. It's nothing uncomfortable. Testing it seems okay, and my math says it should survive it all right. But obviously, when you first turn the power on, because the valve isn't conducting, there's no voltage drop across the anode resistors. So there's full voltage applied to the base connections of these transistors, which means these are going to have about 150 volts across them, and they're still going to be trying to pull 4 milliamps, so they're going to dissipate about 300 milliwatts. It's only going to be for a few seconds, and then the voltage is going to start dropping. They should survive it, but to be honest, there's no harm in putting an HT delay in anyway. It just gives all the valves heaters a chance to warm up before applying HT voltage, so it's something to look into. So yeah, this is just a short update, nothing really much. I can't really show you anything working here. You just it works, but the only thing you can see working is the LED glowing and the valve glowing. This is the power supply setup, how it's going to be in the amp. So one 9-volt winding for the heaters running AC, never 9-volt winding. These ones will be paralleled in this transformer. That's the high voltage AC coming out. So this transformer's running in reverse. It's 9 volts coming in from this transformer, and I'm using the 230-volt winding to run into the heater supply. So yeah, anyway, if you took the time to watch this, as always, thanks for watching, and hopefully have something a bit better. Bit of chassis work and stuff to do next, so next video should have something resembling an amplifier in it, rather than just a couple of circuit boards and some spaghetti wiring on some transformers. So yeah, cheers.